equation of motion along a straight line, right?
Mm-hmm.
I am describing a topic in details. Motion of a particle, motion of a particle along a straight line, along along a straight line, along a straight line with constant acceleration, with constant constant acceleration, right?
Yeah.
Suppose this is a straight line and a particle has to move on this line, and suppose particle has started its motion from this point A at t equal to 0 with initial speed, say you can say this as u, right? And position x equals to 0, and with acceleration a is constant whatever its value, but this is constant, and after some time it reaches at point B where t equals to t and position x equals to x, right? So obviously this distance can be written in the form of x, right? Any
Yeah.
problem?
No, no, no. No.
Okay. Now from the definition of acceleration, now from the definition of acceleration, now from the definition of acceleration, we can write a equals to dv upon dt, right?
Yes.
Here A is acceleration, here A is acceleration, and V is velocity. Must remember, here A is acceleration and V is velocity, not a speed. You may
Ah,
write
you said it had the initial speed
no,
before.
no, 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 no. This V means general velocity, not
I
initial.
mean, like previously, like above the point A,
Yeah,
you
yeah.
wrote the initial speed.
In any point between A and B, you can write this A equal to dv upon dt. But at particular point A, the value of this V is u. And at any particular point say b, this speed becomes say v, right? U, and this is, you can write this as a v initial, and you can write this as v final.
Do you mean initial speed and final speed, or initial velocity and final velocity?
No, no. Must would say I have initial velocity v initial equals to u, and here v final, and here v final becomes v, right? Not a speed, this is velocity. But since this particle is moving on a longer straight line, same
Then
as you can say velocity as a speed, no problem. But on the
okay,
on
because
the
there's
curve,
no direction anymore. It
yeah, yeah,
doesn't matter.
but on the curved line, velocity and the speed will have different values.
Okay, understood, understood.
Here a equals to dv by dt, this is, and I have omitted in this equation vector sign and a equal to dv upon dt. You should understand, here a is acceleration and v is velocity, and this v is velocity, and this v is has any value between u and this v, between point A and B, right?
Okay.
Now you can write this as dv equals to a dt. Any problem?
No.
No. Here A is acceleration and this is a constant quantity. Must remember, here A is acceleration and this is a constant quantity. Now integrating both sides. Now, now integrating, now integrating both sides with its proper limits, with its proper limits. Then we have dv integral equals to integral a dt, and we have limit, if t equals to 0, If t equals to 0, this has value u. And if t becomes this t, t equal to t, this becomes v. You can also write as this is u, and this is v. Any problem, Muhammad?
No, understood.
Okay. And as we know, as we know, integral dv equals to v, right? And integral any constant k multiplied by a function fx dx equals to k integral fx dx provided k is a constant. K is a
Yeah,
constant.
okay, understood. Yeah, because you just like factor it out.
Yeah, yeah. So this will be v and limit u to v and a outside. This will be t and this is 0 to t. So this will be v minus u will be equal to a into t, and you can write v equal to u plus at. In vector notation, in vector notation, in vector notation, v vector equals to u vector plus a vector into time t. Okay, this was final result. V vector will be equal to u vector plus a into t. V means final velocity. V means final velocity. U means initial velocity. U means initial. U means initial velocity. Velocity. A means acceleration. A means acceleration, and T means time. Any problem?
And you went from t, the upper limit is t and the lower limit is 0 by doing um,
Just
t minus 0, right? So that's it. So you get
here,
t.
just a second. First of all, think this V minus U will be equal to A, and this will be T minus 0, right?
Okay, yeah.
So this will be V minus U will be equal to AT, and that's why I have written V equals to U plus AT. Any
Okay.
problem? And
No.
limit means suppose this is fx, and if lower limit is a, upper limit is b, this means fb minus fa, right? For
Yeah.
example, suppose this is sin x, and I have lower limit, suppose pi by 3, pi by 6, and upper limit pi by 3. This means I shall have to write sine pi by 3 minus sine pi by 6. Any problem?
Yeah. No, sorry. No, no problems. I understood.
This was important. For the sake of simplification, this is important. Limit.
Okay. That's only showing like how limits work, right?
Yeah, yeah.
Okay.
And I have proved the relation, and V equals to U plus AT. And look here, you have, suppose here, no, no, no. In this particular case, here, this is, I have proved this. V equal to U plus AT, right?
Yes, yes.
And I shall prove all these formula, right? All this.
Okay. So how did you prove how does s come into this?
Yes, yes. I am describing about that.
So sir, are you doing the you're basically doing the proof, and so this is just for my understanding, or I have to know this proof?
Yeah, yeah. It is important to learn these things. How anyone can write V equal to U plus AT. A basic thing is, suppose any particle has initial velocity U and final velocity V, and particle must should move along a straight line with constant acceleration. If any particle moves along this line, we cannot use this. We cannot use this formula. You cannot use this formula.
Okay.
Can I
Okay.
change? Can I change the space?
Okay, sir. Yeah.
Okay. We have we have we have v equal to u plus at, right?
Yeah.
What is u? What is u? This is initial velocity, right?
Yeah.
In our practical life, this has constant value in any case. This has constant value. Realize or not?
Yes.
Suppose any person throws a ball in this direction, say 2 meter per second. So at this moment, this will be always 2 meter per second. But after that, this can change, right?
Yeah.
But at this moment, this is always 2 meter per second.
Okay.
And v is final velocity, and v is here final velocity, and this is a variable result, variable value. Very, uh, please tell me why, sir. V has a variable value. Suppose any person drops a ball at t equal to 0 from this position, V initial equal to 0. But as time passes, suppose at t equal to 1 second, uh, velocity of this is suppose 1 meter per second, and suppose at t equal to 2 second,
So
this
it's depending
this
on t.
becomes say 3 meter per second, and suppose at t equal to 3 seconds, suppose this is in 9 meter per second, and so on. This is variable result. This is variable, right?
Okay. It's
So
depending on t.
and this is constant. This is constant. This is at this moment.
Okay.
So we can write this as, so we can write so we can so we can write we can write d dx by dt, dx by dt, dx by dt equal, or you can say dr. Position is generally denoted as r. Dr upon dt will be equal to u plus at. Here r is position. Here r is position. R is position. Right? R is position. This is because, as we know from the definition of velocity, v equals to d upon dt of r vector. Any problem, Mohammed?
No, understood. Understood that.
Okay. So that's why dr will be equal to u plus at, and multiplied by dt. Now integrating both sides. Now integrating integrating both sides. Now integrating both sides. We have dr will be equal to u plus at dt, and our limit will be, look here, look back in this page. Initial limit x equal to 0 when t was 0, and finally x equals to x when t will be equal to t, and here initial x equal to 0 and final x equal to x, or you can say
Yeah.
you can say this as r equal to 0, r equal to 0, and this was r equal to x, and
The
initially,
u plus at is a constant, right?
yeah, yeah, here t is 0 and upper limit is t. Did you
Okay.
understand?
Yes, yes, I understood this.
Okay. Now next we have, suppose r, in just a second, suppose this is r integral dr, and from 0 to x, and here you can write this as u dt, u dt plus integral a into t dt dt. Lower limit is 0 and upper limit is t. Lower limit is 0, upper limit is t. And as we know, as we know, integral x to the power n dx will be equal to x to the power n plus 1 divided by n plus 1. Yes or no? Do you know this?
Yes, yes, I understood this.
Very
This
good,
is just
very good, excellent, excellent. And then after this will be r from 0 to x. Here u is constant, so this will be outside, and this will be dt 0 to t, and here a is constant, here a is constant, and this will be t dt dt
ah
0. So this will be x minus 0. This will be t, this will be t minus 0, t minus 0, and here this will be t 1 plus 1 by 1 plus 1, and this will
so
be
t
0
squared
to,
over 2.
right.
Ah, okay,
So
okay.
x minus 0, and this will be simply x will be equal to ut plus a by 2 into t square, and so x will be equal to ut plus half a t square. This will be x will be equal to ut plus half a t square. Ut plus half a. I have proved this, right? Must remember here x is displacement, not distance.
Okay.
Here x is displacement, displacement. Must remember not distance.
So the equation v squared is equal to u squared plus 2as, is the s a displacement or distance?
That is displacement, not distance.
Okay.
Here x is displacement. U is initial velocity. U is initial velocity, and a is constant acceleration. A is constant acceleration. A is constant acceleration. T is time. T is time. In vector notation, in vector notation, in vector notation, we can write, we can write, uh, we can write r vector. Simply r equals to ut. You can write this x also. X will be equal to ut plus half a vector into t square. Any problem?
Yeah. So the reason t doesn't also, because t is a scalar quantity, so it can't.
Yeah, yeah,
Yeah.
yeah. X equals to ut plus half a t square. And in general, we write this usually x equals to ut plus half a t square, right?
Yeah.
And your in your book that was written in the form, this is s equals to ut plus half a t square, right?
S equals ut plus half a t squared. Okay, understood.
And I have proved this these two, v equals to u plus at and s equals to ut plus half a t square, right?
Yeah.
And now I am going to discuss about this. This v square equals to u square plus 2s. Okay,
Okay.
v square equals to u square plus 2s. And this is the last class of, sorry, today is Thursday.
Yeah.
Yes, yeah. And I will take your next class on Saturday, right?
Yeah.
Now, we have again, we have v equals, again we have a equal to dv upon dt. A will be equal to dv upon dt, right? So dv equal to a dt, right?
Yeah.
Now, just a minute. Here we can write dv equal to dv upon dx into dx by dt. Any problem, Mohammed?
dv upon
I have
uh
multiplied and divided by dx both sides, numerator and denominator. Dx. Any problem?
okay, okay, no problem, no problem.
Okay. And here this can be written as v, dv upon dx, but this can be written as v. Any problem? Because dx by dt, any one person can write this as v, right? Yes or
Yeah,
no? And this was acceleration, this was acceleration. So I can write this as v dv equals to a dx. Any problem? V dv equals to a dx, right?
dx, yeah,
Now integrating both side again. Now, now integrating, now integrating both sides with its proper limits. With its proper limits. So V dv equals to integral a dx. Right? Here V dv.
yeah,
We have lower limit u, upper limit v as you know, and dx has lower limit 0, upper limit x.
yeah,
Did you understand, Mohammed, this?
understood, sir.
And now again, as we know, x to the power n dx will be equal to x to the power n plus 1 divided by n plus 1. On this basis, I can write this integration in the form b to the power 1 plus 1 by 1 plus 1, and I have lower limit say u and upper limit v, and here a is constant. This is integral dx and limit 0 to x. So, so v square by 2. So v square by 2, this is u to v, and this is a, and this is x, 0 to x. Any
Yeah,
problem?
no problem.
Right. This is v square by 2 minus u square by 2, right? Will be
Yeah,
equal to a into x. Any problem?
no problem.
V square minus u square equal to 2ax, right?
Yeah,
In vector notation, in vector notation, v square, we can write this as v vector dot v vector minus u vector dot u vector equal to 2 times 2 into a vector dot x vector.
and
Okay.
the x is the s, so it's like v squared is equal to u squared plus 2as.
Hmm. Here v dot v minus u dot u, and this is 2a dot x. And uh, in general, equation is v square equal to v square minus u square equal to x,
Okay,
and
understood.
v dot v minus u dot u will be equal to 2a dot x. Right? This is.
Yeah.
And at last, I have this. How anyone can prove s equals to u plus v into t by 2. U plus v into t by 2. U plus v, s equals to u plus v into t by 2. Can you prove this, Mohammed?
Okay, let me see.
Please try. Please try. How? Here S is displacement. Please remember, S is displacement. Here S is displacement. U is initial velocity. U is initial velocity. V is final velocity. V is final velocity. T is general time. Can I help you?
Yeah.
Okay.
Can you give me a hint, sir?
Yeah, yeah, I am solving this. We have U plus V. U plus V into T by 2 equals to U, and you can write this as V equal to U plus 80, right? V equal to U plus 80. Any problem? And whole multiplied by T by 2, right? Is it
Well,
okay?
I didn't understand.
Okay, now I can write this as U plus
I didn't
U.
understand.
Understand or not?
No, I didn't understand.
This V equals to
Ah, okay, okay, okay.
this is V equal to U plus 80, right? So this is 2U plus 80, right?
Yeah.
Plus 80 multiplied by T, and this is 2. So 2U plus 80 multiplied by T by 2. And now this is 2UT plus 80 square by 2, and I can write this as 2 into UT by 2 plus 80 square by 2, right? Cancel, and this equals to UT plus half AT square. And I proved this. UT plus half AT square equals to UT plus half AT square equals to X.
X. Yes.
So we can write this as S. And here I proved this. This was RHS, this was RHS, and this is LHS, right?
Yeah.
Okay, very good. Can I change this page, Mohammed?
1 second, sir.
No issue.
Okay, sir. Yeah.
Okay, one more lesson is distance traveled in a second. Distance traveled in a second. Distance traveled during a second. Right. This is also an important part. How anyone can find distance traveled during a second. Right.
Yeah.
I am describing this. Suppose any person has started its motion from here t equal to 0, and say u equals to u initial, I mean v initial equal to u, v initial equals to u, starting with constant acceleration a equal to constant. Motion must should be along a straight line, and here suppose t equals to 1, this point is a, suppose this point is b, here t equal to 2, say this point is c, here suppose suppose this point is d, and you can write this as t equal to 3, and here suppose this point is t equal to 4 and this point is e. Particle moving, speed velocity increases this, increases this, increases this, increases this. V final increases as time increases, V final increases, right?
Yeah, because the acceleration is constant.
Yes, yes. AB, AC, AD, and A. What can you think about AB? Please tell me. What is AB?
AB is in this distance.
Displacement of particle In 1 second,
Yeah.
displacement of particle
Is placed on a particle in 2 seconds. The idea is displacement of particles in
in one
three, and
second, right? Displacement of particle in 2 seconds. Displacement of this is displacement of particle in 3 seconds, and this is displacement of particle in 4 seconds. Right? Any problem?
no problem.
Very good. What do you think about CD? I am writing
See,
this.
wait
I am
1 second.
writing displacement, and displacement of particle in third second. Is it clear or not? CD.
Displacement of
1 second.
particle.
Just a bit. 1 second completes here, right?
Yeah.
And second starts from point B.
Yeah.
2 second completes at point C, and after that third second starts. And at point D, 3 second complete, and after that fourth second starts. Right?
Ah, yeah. So it's the displacement of the particle in the third second, not 3 seconds.
Yeah, exactly.
Okay.
And CD can written in the form as AD minus AC. Yes or no?
Yeah.
Okay. So this is displacement S in t equal to 0 to t equal to it is t equal to 3 minus, and this is AC, t equal to 0 to t equal to 2. Is it okay?
Okay. Understood.
Okay. Generally, it is represented as S3 minus S2, right? And this is S third. This is S third. This is S third. Any problem?
No. No.
Similarly, S nth. Similarly, similarly, S nth will be equal to Sn minus Sn minus 1. Any problem?
Let me
If
see.
if I write third, then it means S3 minus S2. So
Yeah.
if I shall write Snth, this means Sn minus Sn minus 1.
Understood. Yeah. So, for example, if S nth was S third, it would be Sn, which is 3. So S3 minus Sn.
Exactly, Muhammad, exactly. Very good, excellent. Un plus half an square and minus un minus 1, u un minus 1 plus half a n minus 1 square. This is so this will be un plus a n square by 2 minus un minus u plus a by 2 into a square plus b square minus 2, right?
Yeah.
Un plus an square by 2, and this will be minus
My.
1, this will be plus u, this will be minus a by 2 into n square plus 1 minus 2. And here this cancel out, and here u plus an square by 2 minus a by 2 into n square minus a by 2 plus a by 2 into 2n. This cancel out. This also cancel out. So u plus a by 2. So u
Wait,
plus
U minus A by 2, right? U minus?
yes, just a second. I am arranging this. U plus say common a. This is n minus half, right? Look here. I have written a first, a common, n minus 1 by 2, right?
Okay, okay.
So this will be u plus a by 2 into 2n minus 1. Any problem?
No.
So this is u plus a by 2 into 2a minus 1. So that's why I have written s nth. S nth will be equal to u plus a by 2 into 2n minus 1. In vector notation, S nth will be equal to u plus a vector by 2 into 2n minus 1 into 2n minus 1. Any problem? This is very, very important.
Okay, understood.
In more general case, this is used normally. S nth equals to u plus a by 2 into 2n minus 1.
Okay.
Right. And now, please solve a question. Can I change the space? Yes or no?
Yeah, you can change.
And please revise all formulae. I have v equal to u plus at. I have s will be equal to ut plus half at square, and I have v square equal to u square plus 2s, and I have s nth will be equal to u plus a by 2, u plus a by 2 into 2n minus 1, right?
Yeah.
And v vector equal to dr upon dt, and a vector equals to dv upon dt, right?
Yeah.
Now I have a question. An object, an object having a velocity, having a velocity 4.0 meter per second is accelerated, is accelerated at the rate of at the rate of 1.2 meter per second square for 5.0 second, or 5.0 second. Find the distance traveled. Distance traveled during the period of acceleration. Period of acceleration. Please solve this. Very easy. Very easy.
Is it 94? 94 meters?
No, no. Just a second. Just a second. Answer is 35 meter.
Oh, I put it into the S nth formula. Oh, sorry, I
During
for
the
inter-
no, no,
so I
no, no, Muhammad, no, Muhammad, no, Muhammad. This is during the acceleration, and period of acceleration is from t equal to 0 to t equal to 5. Right? Period
uh
of period of acceleration is period of acceleration is from t equal to 0, from t equal to 0 to t equal to 5, right?
yeah.
And now solve. Don't use this formula. This formula is used in this case
So why can't we use the S nth formula?
because this is not asked as fifth. This is not our question. This our question is S5. This means s at from t equal to 0 to t equal to 5, right?
Ah, okay. Understood, understood, sir.
U equals to 4, t equals to 5 plus half. A equals to 1.2 and
Hmm.
t is
I got 215 meters.
right.
Okay,
This
understood.
is
And then the I think
0.6 into 20.
5.4 meters, that's the one that's traveled on the fifth second.
From t equal to 0 to t equal to 5, whole distance traveled by the particle is this. S equal to t plus half t square. And if any one person asks S fifth, then our answer is 4 into 5, sorry, 4 plus 1.2 by 2 into
I
2
thought it was
and
40, right?
2
40?
into 5 minus 1, right?
So it's 40, right? Not 4?
Just a second. S fifth, u plus a by 2 into 2 n minus 1, correct. And ut plus half t square, here we have u4
But
t5.
sir, is it 4.0 meters per second or 40 meters per second?
No, 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 this is 4.0.
Ah, okay. It looked like 40 meters per second
No,
in
no,
the question.
4.0 into
Okay.
t is 5, right?
Okay.
This is 20, right?
Okay. Yeah.
And after this, 20 plus 25 into 6 by 10. And this will be 35 meter, right?
Yeah.
Any problem?
No.
Okay. In the next class, I will discuss vertical motion under gravity, right?
Yeah.
Uh, here, hmm, this is understand how to make use the independence of vertical and horizontal motion. No, no, no. This is in this case where here a will be equal to g, right? In this case, where a will be equal to g, this will be called vertical motion under gravity. In the next class, I will discuss, right?
How many of these have we finished so far?
I have finished this one. And then, or you can say, in the next class, I will discuss this. Be able to draw and interpret displacement time, velocity time graph, AT graph,
Okay.
right?
Yeah.
Okay.